क्या हुआ ब्रो? क्या सोच रहा है? Bro, I want a career in tech, but I don't know where to start from. I wish there was a platform जो मुझे मेरे पेस पे मेरे पसंद के कोर्सेज सिखा पाता in my languages. क्यों? तूने लॉन्चपैड का नाम नहीं सुना? हाँ, no. What is that? Launchpad is a wonderful initiative started by Newton School, under which you can learn the basics of any programming language from the scratch. It doesn't matter if you have any background in tech or not, it helps you prepare from a very scratch level to the amazing full stack developer within just 6 months. It has courses starting from object-oriented programming, OOPS, Java, data structure algorithms, React.js, Node.js, Python and everything. And not just that, it has courses in English as well as in Hindi in case if you don't feel comfortable with one of the languages. Newton School has a tie-up with more than 300 best companies across the country, and it makes sure that its developers or the students are placed with one of the best companies in the country. ऐसे थोड़ी होता है, कुछ भी Okay bro, मत मान. Excuse me brother, please link दे दो यार, please. The link is in the description. Hey guys, welcome back to Tech with Devang. Hope all of you are safe and doing well. This is your friend Devang Sharma, software development engineer at Cisco and your host and mentor for Complete Java series. This Complete Java series in collaboration with Newton School is an initiative to help you become a professional developer in Java. It doesn't matter if you are a freshman, a junior developer or a senior developer looking to excel your skills. I'm pretty sure there will be something for everybody in this tutorial. Starting with the JDK JVM working basic levels to the most advanced level of Spring Boot, microservices architecture and Hibernate. There will be something that you can utilize from this Java series. With that being said, without a further ado, let's start the video. In today's video, we are going to cover a very important topic, Hashmaps. Hashmap is not only important from interview perspective, but even for competitive exams. For example, GATE. You can easily find 2 to 4 questions every year being asked from Hashmaps only. So, irrespective if you are preparing for interview or irrespective of preparing for your competitive exams for GATE or higher education, this topic is extremely important for the same. Let's start diving deep into it. So you must have heard about that hash maps are actually key value pairs. But how does that key value pairs are implemented? What is the use case of it? What is the internal working of it? That is some of the questions that we are going to answer in today's video. Starting with the topic of hashing first. Hashing is nothing. Hashing is just a process of converting an object into an integer value. Now here's the question. Why are we converting an object into an integer value? What do we gain out of it? Of course, that integer value actually helps as indexing and faster searches. Here's a point I would like to make. The ultimate use case of using a hash map is to search and retrieve the data in O1 time. O1 time means constant time. So, but that is the best case scenario. If we are not able to retrieve and insert the data in O1, it should go for as less time as possible. That is why the integer value helps in indexing to the hash table and for faster retrieval and insertions. Let's start with the topic first. What is Hashmap? Hashmap is part of the Java collection framework which implements the map interface. Now, here's one very important thing. Hashing is an algorithm or a concept and Hashmap is a data structure. There are other data structures that are built on that concept of hashing. For example, hash set. In case of C++, we called maps and set. In case of Java, we called it Hashmap and hash set. As you can see, the hashmap stores the data in the pair of key and value. Hashmap contains an array of nodes. I repeat, an array of nodes, and the node is represented as a class. It uses array and linked list data structure internally for storing key and value. I would like to make one point here. In the recent upgradations of Java, if you see Java 8 and Java 9 internal working, they use red flag trees in case of linked list. Now to understand it, there are 4 fields in Hashmap. Let's understand these 4 fields. As you can see, first is the node, which is the key and value pair. Then the 4 fields are hash, which is the hash value of the object, key of the object, b is the value, and then a next pointer. Next pointer is similar to what you see in a linked list. Before we understand the internal working of Hashmap, there are some terms that we need to be clear with. Equals, hashcode, and buckets. Let's start with the first, equals first. Equals is a method which checks the equality of two objects. Now when I say objects, I'm talking about the key. If the key are same, if they are equal or not. It is a method of the object class. Apart from that, it can be overridden. So if you override the equals method, it becomes mandatory to override the hashcode method as well. Which brings to our second part, hashcode method. This is again the method of the object class. It returns the memory reference of the object in integer form. So this is what we call the hash function as well, which helps in getting the hashcode value of an object in integer form. The value that you receive from the method, which we used as an index in the bucket, or we call it bucket number. The bucket number is the address of the element inside the map. Hashcode value by default of null key is 0. Well, it makes sense as well. Last but not the least, buckets and hash table. Array of the nodes is called buckets. Each node has a data structure like a linked list, which contains multiple nodes out of it. We will understand why do we need multiple nodes for same references. More than one node can share the same bucket and it can be in different capacity. This is somehow allocation looks like in a bucket. So you can see this is a bucket and we have 0, 1, 2, 3. These are my indices. But you can see for each node, the value is key for 21, value equal to 89, and we have a next pointer. And in case of the node which is at reference 1, I can see it is pointing to other node as well, and it's pointing to third node as well, with the value 67 and 55 respectively. This is how a linked list structure is created at the reference end in a bucket. In the case of our node which is reference 2, you see the key value is 34, but it does not have any other node in it. Similarly, in the third case you see key 71 does not have any other node in it. So this is the way the allocation is done in the bucket. Now let's understand two very important functions in Hashmap. These are put and get. Put is used to insert the key value pair, get is used to retrieve the data. So put is used for insertion, get is used for retrieval. Let's start with the put first. We use put method to insert the key and value pair in Hashmap. The default size of Hashmap is 16. So the value of indices will be 0 to 15. Let's take an example. If we want to insert 3 key value pairs in Hashmap, I declared a Hashmap of where my key is string and my value is integer. And I declared that Hashmap and I put 3 values. Aman, which is a string and integer 19, Newton School with the value 29, and Launchpad with the value 39. Now just to understand at which index which key value will be saved, right? So we call the put method. So the first thing that put method does is it calculates the hash code of the string or any value that you have done. So let's take the example of the Aman. So suppose the hash code of Aman is 2657860. To store the key in the memory, you first need to calculate the index of Aman. Let's see how do we calculate the index. Calculating index actually requires a formula, and the formula for calculating the index is hashcode key binary and n-1. So you see here, the hashcode value was 2657860 and 16 minus 1. So we do a binary and we get the value 4. N is the size of your array. So hence we get the calculate index of Aman is 4. So this is your memory representation, which will have values from 0 to 50. So at 4th index, you will have Aman, its value in the next pointer, and this is the key value that you got, 2657860. And the index that you got is 4. So it is stored at the index 4 in the hash table. Now you must be thinking, there can be case where the calculated index value might be same for 2 or more keys. Let's assume another example. You calculate the hash code for another key, Sunny. Now let's suppose the hash code that we get for Sunny is 63281940. Now to store the key in the same memory, you need to calculate the index just like we did the last time. We calculate the index, we get the same index as 4, which was with Aman as well. Now the value 4 is the computed index that will be stored in the hash table, right? So in this case, equals method check that both keys are equal or not. If they are equal, it will replace the value with the current value. Otherwise, it will connect the node to the next existing node. So you see, both the values of Aman and Sunny, they will be placed at the index 4 only. But how it will happen is, initially Aman came first, so the first node that is pointing to the Aman will be stored at the index 4, and the next node will be pointing to the next node of Aman. which is the Sunny node. This concept is called hash collision. So collision is what? When two or more objects have the same hash code value. This condition is called collision. And to avoid this collision, we use multiple methods like open addressing and separate chaining. And these methods are called hash collision. One of which methods include creating a linked list out of the structure. There are some other examples as well. Example, linear probing and quadratic probing, polynomial probing, and so on. Similarly, we want to store another data with, let's say, the string value as Ritesh. So suppose you get the hash code as 2349873. So you calculate the index come out to be 1 using the same formula. The formula is this, 298373 and binary and 16 minus 1. So you get the value as 1. So at one index, Ritesh will be stored, and fourth index, there will be two nodes that will be stored, Aman and Sunny. I hope you get to understand the working of put method. Now let's go to the working of get method in Hashmap. Get method is used to get the value by its key or for retrieval. It will not fetch the value if you don't know the key. When a get method is called, it first calculates the hash code of the key. Let's take an example and understand it. Suppose you want to fetch the key Aman. So these are the methods that will go through. First it will go is map.get new key Aman. So first of all, it will get his hash code value. As you see, the hash code value is 2657860. Now it will calculate the index value using by index formula. We get the index as 4 as we got in the previous example as well here. So to calculate the index value as 4. Now you have calculated above get method, right? So that it will first go to the index value of 4 and it will check if the keys are equal, it will give you the value. If in this scenario, you can see it is found as first element of the node and will return the value 90. But consider in case of Sunny, right? In case of a Sunny, the first value is not that. Sunny is the second value, right? So in that case, what will happen is, first it will traverse to Aman and then it will traverse to the second one. So it's like a linked list traversal it will perform during the retrieval or get function. So complexity, you can understand, complexity will be big of n in the worst case. Until the traversal will complete until the next node becomes null in the linked list. In case no node is found, the map will return none. With that being said, hope you guys have understood the internal working of Hashmap in Java, the use of both put and get function, the words like equals, hashcode, and bucket, and how they are implemented using formula. That's it for this video, guys. If you like this video, make sure that you like it, comment it, share it among your friends, and do subscribe to the channel. Don't forget to mention what is the next topic you want in the comment section. I will see you in the next video with some other interesting topics. Thank you.